All right, welcome to lesson 7, the measure of an arc. We're going to go through and just talk about these today, so I'm waiting for the video to post from the live stream, but until then, I'm going to provide this one. So starting with the first one, we know the measure of angle GBF, which is this angle right here, is 17 degrees, okay? And so we're going to be talking about a few theorems today. So the first one is this guy. So angles, inscribed angles that intersect the same arc are congruent. So we know that if these two angles, angle A and angle C, intersect the same arc, right, arc BD here, then these two angles have to be equal to one another, okay? Likewise, on the other side, we have the same thing going on with angle B and angle D. Both of these angles, all right, intersect arc AC and have the same intersected arc, therefore they're congruent. So with this diagram here, since this is 17 and it creates this intercepted arc, every other inscribed angle, which includes angle H or GHF, angle C here, angle GCF, okay, angle D, angle GDF, and we have this angle at E, angle GEF. These have to all be equal to 17 as well. So those angles are all congruent. They're inscribed to the same angle, okay, the same arc, therefore they have to be equal. Going down to the second one, what is the measure of angle GAF? So GAF, if you look at it, okay, we're going to just get rid of this stuff so far. So GAF is right here. Now we know, remember from the get-go, that this angle GBF is 17 degrees. So this arc has to be, it's inscribed. So going back to our notes here. An inscribed angle, okay, is vertex is on the circle, okay, and it's half. So inscribed sounds like inside and it's half. So the measure of the arc, okay, is 2 times the measure of the angle. The measure of the measure of the angle is half the arc. So if this angle right here is 20, then that arc is going to be 40, okay? And a central angle is located at the center of the circle. So, and this is the same as the arc, all right? So if this is 17, this is double that, so this is 34. And the central angle is also going to be the same as that, so this is 34. Just real quick, okay? All right, so 34, since it's the central angle and is the same as arc GF. And the last one is angle BAD. So angle BAD is the central angle going in the other direction. These two angles are vertical, so this is also going to be 34 degrees. So BAD is vertical, the GAF, or you can say that they're congruent, since vertical angles are congruent. Therefore, it's going to be 34 degrees. Okay, going to the next page. If we started with an inscribed angle and minor arc between A and C, so if we knew that this was an inscribed angle, then we would know that this angle, right, is measure of that arc has to be twice as big. Okay, another exercise down at the bottom here. So these arcs, arc BC, arc CE, arc ED, and arc BD, let's switch colors there, are all given to us as they're in a ratio of 1 to 2 to 3 to 4. Now these 4 arcs actually create the entire circle, which has 360 degrees. So the way we do this question is we let x equal our scale factor. What number are we going to multiply these numbers 1, 2, 3, and 4 so that we end up getting 360 degrees? So we know that arc BC has a measure of whatever x is. CE is twice as big. ED is 3 times as big, and DB is 4 times as big. So all of these arcs together, we know x plus 2x plus 3x plus 4x have to equal to 360. So whenever we get a ratio question, we want to put an x on those numbers and then create an equation from those. Okay? So that's what we're going to do here. So x plus 2x plus 3x plus 4x is 10x. And then when we divide out by 10, we get x is equal to 36. So now we know the measure of the arcs. This is 36. CE is double that, so it's 72. DE is 3 times that. That's 108. 3 times 36, okay? And then 4 times 36 is 144. So now we can figure out the measures of the angles. Angle BAC here is just going to be central, so this is 36. Angle DAE is this inscribed angle down here. So that's going to equal 108.
102.
Arc DB is this red arc right here, which we already know the measure of, which is 144. And this arc, this angle, I should say, CED, is actually going all the way from here to here. Not that much, you're good, that's it. Okay, so this is the sum of 72 plus 108, which, as we're looking at the circle, right, is actually this half circle right here. So that should be 180. All right.
All right, I'm going to make something else with this red.
Okay, so going to the next question. In circle B, AB is equal to CD. So we know that these two lines are equal. Okay, and if they're equal, these are also the radii. That means that all of these lines are actually equal because these are all radii, and CD was equal to AB. So that tells us really that this triangle is actually equilateral. And all of these are equal to 60 degrees. Okay? Okay, so since that angle now, we know all those angles are 60 degrees, that tells us that the angle next door to it right here has to be 120 degrees. Okay? And this angle really is formed by this half circle here. So we know that this is 180 degrees here. All right? And remember, these are all central angles, so they're the same as the arc. Okay? All these arcs and angles are going to be 60, 120, and 180. So arc CD is the arc with the central angle of 60, so this is also 60. Arc CAD goes from the 120 degree arc plus the 180 degree arc, so it's going all the way around from C through A to D. Now this type of arc is referred to as a major arc. So if we go back to our notes real quick, okay, major arcs, all right, are arcs that are formed that are more than 180 degrees, and we use 3 letters to talk about them. So that we could call this arc ADC, or arc AEC, or CEA, or CDA. Minor arcs are always more than 0 but less than 180, okay? And those arcs we would use 2 letters for, like arc AC here, or CA. All right, so that's what we want to keep in mind here as we're working along, is that the major arc versus the minor arc, and then the other one what we call is a semicircle, okay? So semicircles are exactly equal to half a circle, so they're 180 degrees. All right, getting back into our question. So this gives us an arc of 300 degrees. And then arc ACD would be from A through C to D, and that would be 180 degrees. That's a semicircle. All right. Number 3, BC is a diameter, DCA is 100. We know the measure of arc EC is 2 times the measure of BD. So this arc, whatever this is, we'll say X. This arc up top, CE, is 2 times that. So we just need to figure out the measure of those arcs, and we'll be able to answer the rest of the question here. So, all right, we know that this arc or this angle is 100 degrees. So this arc is, since it's a central angle, is the same. So x is equal to 80. 2x is equal to 160. And then this arc over here is going to be 20 because it forms the semicircle here with a diameter. So angle BAE is a central angle. It's the same as that arc. So this is 20 degrees, not drawn to scale. Arc EC is that 2x, which we said was 2 times 80, or 160. And arc DEC starts at D, right? Goes all the way around through E and over to C. So this is equal to 80 plus 20 plus 160, which is going to equal 260. And we also could say that it's really just 360 minus this arc, right? It's the rest of the circle, take away that 100. For number 4, angle CAD is 37, okay? So CAD is going to form this arc right here. So this arc is going to be 37 degrees as well. All right. This arc going all the way around here is basically the difference between that and 360. Throw 360 minus 37 is equal to 2. How about 3? 323. All right. And that's the measure of arc CBD. Angle CBD is this inscribed angle to this 37-degree arc. So it's equal to 37 divided by 2, which is 18.5. And angle CED is weird. That's the angle that's drawn right here. So this is technically another inscribed angle, and its arc is that first arc, right, that we said was 323. So inscribed means it's half, so it's 323 divided by 2, which is 161.5. That's the measure of that arc. All right, continuing on here. We have a couple theorems to talk about. Number 1 is the inscribed angle theorem. Just remember that that inscribed angle is half the measure of its arc, okay? And that all circles are similar. So these two circles are going to be similar to each other since the radii are always going to be the proportional. So R2 and R1, always, no matter what you do, any radius you draw in circle 2 is always going to be in a ratio with the circle in R1. An arc is just a proportion of the circumference of the circle. Remember, minor arcs are between 0 and 180. Major arcs are greater than 180. Semicircles are equal to 180. An inscribed angle is the vertex is on the circle. It is half the measure of the angle. Okay. Central angles are located at the center of the circle. Remember, central is the same. Okay. And an intercepted arc is between the endpoints of the arc and the circle, the arc that goes between those. Okay, jumping over to number 2. Actually, we are, but we need to do number 1 first, Kate. So number 1, we're starting with this information. So I would like to pause it here and have you try it on your own, and then we'll go through it. So go ahead and pause, try it, and then we'll go through our work together.
I'm going to put the music on.
No. Okay, so angle A is 50 degrees. That's angle CAD. This is a central angle. So the arc here is also 50 degrees. Okay. And then the other angle that's being formed here is an inscribed angle at B. And this angle is half the measure of that arc. So this is going to be 25 degrees. So we can name the central angle. There is one of them. Okay. I'm just going to switch font here a little bit. So we have angle CAD or DAC, that is our central angle. Angle CBD would be our inscribed angle. This angle BDA, I wouldn't call it inscribed because the vertex here, like this ray for our angle doesn't end up on the circle. So it's not exactly inscribed, but I'll look into that for you guys and tell you what I come up with here. A chord could be BD. or BC, because it extends from B to D, that is on the circle, so the endpoints are on the circle there.
It extends.
Minor arcs, there's a few of them. There's DC, from D to C. There's BD, going from B to D. And there's also CB, which is going from B to C. Now, when we state an arc, we need to draw the little arc hat on top for these. And these would get straight lines, because they're line segments. So major arcs, remember, get 3 letters, okay? So here the major arcs go from D through C to B, so DCB, or BCD, and also going from D around B to C, around B to C. And you also could say it goes from C to B. We would want another letter up there. Let's say we put a point up here and call it E.
2.
Okay.
Call it 2.
Interesting, Kate. And we could come up with those arcs, but those are the arcs we're referring to. So from B all the way through to C, from B all the way through to D, okay, and we'll go green. From D all the way through to C. Those would be our major arcs here, okay? So we want to put the arc hats on top. And then we can go figure out the measure. So the measure of arc CD we said was 50 because it's a central angle there. CBD, right? C through B to D is essentially 360. And then we're taking away the 50-degree arc. So this is 310. And then that's arc CBD. Angle CBD, remember, is the inscribed angle there. So that is 25 degrees. Okay. On to the next page, number 7. We want to find the measure of each minor arc. So once again, we have an inscribed angle, and I would tell you to pause here, try it on your own, and then check it. So this angle is 32. This arc is double, it's 64. This central angle is the same. And then on the other side, we have another central angle right across the way here. These angles are vertical. So then this arc is also 64. And then basically from there, this arc creates 180 with arc EB. So this is going to be 180 minus 64, which is 116. And then this angle is 116. This angle is 116. So this arc is 116. And there's the measure of our arcs and angles. For number 3, go ahead and pause again here.
No.
Okay, thanks, Kate. Remember that these lines are the radii, so these are equal, meaning that this triangle is isosceles.
The radii.
So these two angles are 40 degrees. Okay. This arc here, we use a couple of, now there's really a couple different ways to do this from here, so keep this in mind.
Call it 2.
What we can do here
Call it 2, though.
is talk about this angle as being inscribed. So this arc is double that, which is 80 degrees. This arc is 100 degrees. Therefore, this angle is 100 degrees. And this angle is 80. We also could add together the 40 and 40 and get 80, and then subtract from 180 to get the measure of that angle there to be 100 as well. And then we could do 180 here, and then do all that stuff. So let's go through and answer these questions. Angle BAD, we already talked about, is 100 degrees. Angle CAB was that 80-degree angle. Arc BC is central to that, is the inscribed arc to a central angle, so it's 80. Arc BD also inscribed to a central angle. And BCD is going all the way around the circle from B through C, ending at D. So remember, this is half a circle, this is 80. So this is equal to 180. Sorry, I don't know why I said 80, 180. And then we're going to add on that other 80-degree arc here. And that's going to be 260 degrees. And that's BCD. All right. For number 4, we're going to find the measure of x here. So once again, go ahead and pause, try it on your own. Okay.
Daddy.
Angle E is inscribed.
Dad.
So if this arc is 66, we're going to double it to get the measure of
2.
you're right, times 2.
Yeah.
And that is equal to 132 for this big arc right here. But remember, these two arcs are equal, BF and BD, so they're actually both 66. Therefore, this angle is half, since it's a inscribed angle to the 66-degree arc. So x is equal to 66 divided by 2, which is just 33 degrees. On the next page, we have number 5. So once again, pause if you need to. All right, we want to find the measure of angle DEC. So if we find that angle first, okay, which means I need to really get this arc. That's my job. Get that arc, I can get that angle. So the other angles we have is the central angle. So this arc down here from B to C is actually the same. So this is 126. And I have an inscribed angle over here from BED. And if this is 32, this is double, so this is 64. So that arc over here is 360, take away the sum of 64 and 126. So 360 minus, that's 10, 8, 190 is going to be our answer. And I believe we get 170 here. Which it is.
Which it is not.
So this angle is inscribed to that 170-degree arc. So the measure of angle DEC is 170 divided by 2, which is 85 degrees. Okay. Question number 6. What I want you to do is we're going to ignore this right here.
Let me see.
Okay.
Let me see.
What we know is that K is the midpoint of CB. So really what happens is this. If this is the midpoint of this, we draw this line in, which is already done from the diagram down here. So we're just going to use this bottom diagram. We're going to use this diagram right there in a second, okay? These two angles have to be equal. Likewise, if J is the midpoint of B, looks like D, okay, then this is cutting in half. So this inscribed angle here, when we draw a line C to J here, this is also going to bisect this angle, okay? So this is important for getting the rest of these angles here, all right? It says to join these lines, which it has done already in the bottom here. Now we are going to ignore this stuff, okay? Our job is going to be to just go through.
Ignore this stuff.
You got it, Kate. Ignore that stuff. You tell them. All right. And go figure out the other arcs and angles based on the diagram. So we know that this arc, remember, this angle was 74. So we cut that in half. We end up with 37 and 37. These two arcs are equal. And we can see the two inscribed angles being formed. So each of those arcs has to be 74 degrees because it's a double 37-degree angle. All right. Likewise, we have this 42-degree angle that we just cut in half. So each of these would be 21 and 21.
22 and 21.
Okay. And therefore, these two arcs have to be 42 degrees each. So we can actually start answering some of these angles, right?
No.
Angle A is inscribed to this 42-degree arc. So angle A is half of 42, which is 21. All right.
Technically 22.
Angle D all right, angle D, just trying to find a color that works here, is inscribed to the 74-degree arc.
I bet you don't know this one.
So angle D
100 plus
divided by 2, which we know is 37. So that's the measure of angle D. And to get the measures of angle B and C, right, we're actually going to need, here's C. Well, let's use a different color. We already used that one. I'll use green. Okay. C is actually using this arc right here. And so is angle B. it's also using that same arc. So C and B are actually equal, and they're equal to whatever half of that arc is. So we have all of the arcs on top. We have 42, 42, 74, and 74. So we just take 360 and we subtract those amounts away. So really you're going to take away 84, which is 42 and 42, and 148, which is 72 and 72. And if we subtract those, we're going to get a difference of 128. So the measure of this arc down here is 128 degrees. And B and D, or C and D, are both half of that. So angle C is equal to 128 divided by 2, which is 64. And that means that angle B is the same thing. Okay? So the question they want answered, thanks, is angle CKJ and KBD. Angle CKJ is actually a combination of angles C and D. That's this angle, okay, right here. All right, that's C and D. So that equals C was 64 plus D, which is 37. We add those together and we get 101 degrees. All right, the other angle we want is angle KBD, okay, which is this angle right here, which is a combination of angles A and B. So 21 plus 64 is 85. And there's the measure of those two angles. All right, guys, that's it. That's Unit 7. Just some good practice with the angles and arcs. All right, and I'll see you guys tomorrow. We'll try to do a live stream later today. Have a great day, guys.